Greetings to all my tech heads out there in the KevTechify Nation, and if you're new here, welcome. In this episode, we're going to look at IPsec protocols. We'll be discussing an IPsec protocol overview, authentication headers, encapsulation security protocols, ESP encrypts and authenticates, and finally, we'll look at transport and tunnel modes. This episode is part of my series on network security for the CCNA. I'm Kevin here at KevTechify. Let's get this adventure started. The two main IPsec protocols are the Authentication Header, also known as AH, and Encapsulation Security Protocol, known as ESP. The IPsec protocol is the first building block of the framework. The choice of the Authentication Header or the Encapsulation Security Protocol, AH or ESP, establishes which other building blocks are available. AH uses IP Protocol 51 and is appropriate only when confidentiality is required or permitted. It provides data authentication and integrity, but it does not provide data confidentiality. It does not provide encryption. All text is transported unencrypted. The Encapsulation Security Protocol, ESP, uses IP Protocol 50 and provides both confidentiality and authentication. Authentication provides data origin authentication and data integrity. The authentication header is applied to the entire packet, except for any IP header fields that normally change in transit. Fields that normally change during transit are called mutable fields. For example, the time to live field is considered mutable because routers modify this field. The authentication header process occurs in this order. First, the IP header and data payload are hashed using the shared secret key. Next, the hash builds a new authentication header, which is inserted into that original packet. Third, the new packet is transmitted to the IPsec peer router, so it transfers it across that network to the other end of your IPsec. And finally, that peer router hashes the IP header and data payload using that shared secret key. And it extracts the transmitted hash from the authentication header, and it compares the two hashes together. The hashes must match exactly. If one bit is changed in the transmitted packet, the hash output on the received packet changes and the authentication header will not match. Authentication header supports MD5 and SHA algorithms. If encapsulation security payload is selected as the IPsec protocol, an encryption algorithm must be also selected. The default algorithm for IPsec is 56-bit DES. If you don't use DES, you can also use ESP here. This is for ESP. ESP can provide integrity and authentication. First, the payload is encrypted. Once it's encrypted, next, that encrypted payload is sent through a hash algorithm. That hash provides authentication and data integrity for the payload. Optionally, ESP can enforce anti-replay protection. So ESP here can also enforce anti-replay protection, which refers that each packet is unique and is not duplicated. This protection ensures that the hacker cannot intercept packets and insert changed packets into the data streams. Anti-replay works by keeping track of the packet sequence numbers and by using a sliding window on the destination end. When a connection is established between a source and a destination, their computers are initialized at 0. Each time a packet is sent, a sequence number is appended to the packet by the source. The destination uses the sliding window to determine which sequence numbers are expected. The destination verifies that the sequence number of the packet is not duplicated and is received in that order. When both authentication and encryption are selected, encryption is performed first. One reason for this order of processing is that it facilitates rapid detection and rejection of replayed or bogus packets by the receiving device. Prior to decrypting the packet, the receiver can authenticate inbound packets. IPsec was initially established to provide security for IPv6 packets. Therefore, the IPsec implementation for IPv4 and IPv6 are similar as far as the standards are concerned. In IP version 4, AH and ESP are IP protocol headers. IPv6 uses the extension headers with a next header value of 50 for ESP and 51 for AH. In transport mode, here we have transport mode, security is provided only for the transport layer of the OSI model and above. Transport mode protects the payload of the packet but leaves the original IP address in plain text. The original IP address is used to route the packet through the internet. ESP transport mode is used between hosts. Tunnel mode, right here we have tunnel mode. Tunnel mode provides security for complete original IP packet. For the complete IP packet. The original IP packet is encrypted, then it's encapsulated in another IP packet. This is known as IP in IP encryption. The IP address on the outside of the packet is used to route that packet through the internet. It was my pleasure to provide you with this wonderful episode on IPsec protocols. If you like this episode and you got value out of it, and depending upon what platform you're using, please click that like button, give a 5-star rating, leave a comment. This all helps me bring you more great content. Please take a minute to subscribe to my channel. All of my socials and contact information are on my website, KevTechify.com. There you can find out how to get all these episodes in video and podcast form. In the upper right is my playlist for my series on network security for the CCNA. In the bottom right is one of my favorite videos that I picked just for you. Thank you so much for watching this episode of my series on network security for the CCNA. I'm Kevin. This is KevTechify. I'll see you next time for another great adventure.